Hi, my name is Joshua Gombo, and I'm a PhD candidate at University of Washington in Seattle. This is a work I did with my colleague Anuj Tiwari and my supervisor Professor Santos Devasia. The focus of this work is to develop a method for cohesively transporting flexible objects using decentralized robot networks. A decentralized approach is preferred due to several advantages, which include robustness to failure, scalability, and versatility as compared to a centralized approach. However, the challenge is to maintain network cohesion, that is to have all robots move in similar manner during transition from one state to another. Current decentralized theories only ensure cohesion at the end, but not during transition. In an object transport task, this is important in order to avoid excessive deformation that can potentially damage the object during transport. And thus, the problem here is to improve the cohesion during transport for similar task completion time. So in our paper, we propose a method to allow the object to be transported more cohesively using delayed self-reinforcement or DSR. The advantage of this approach is that it can be implemented using only local information without additional network information. And this is done by modifying a standard consensus approach with added delayed information of itself to reinforce the response. And as a result, all robots now move more cohesively, and thus it reduces the deformation during transport. We then validated our proposed approach with physical experiment, which consists of 4 custom robots carrying a spring as a flexible object. The goal of this experiment is to transport the object over 50 cm of distance, as well as to reduce the deformation without changing the task completion time. Note that only Robot 1 has access to the desired trajectory, shown as a virtual source. Here's a side-by-side comparison of the results with and without cohesive DSR. It is shown here that without DSR, the deformation during transport is quite large. In contrast, with cohesive DSR, the deformation is reduced significantly by almost 90% while completing the task at the same time. In conclusion, the cohesive DSR improves cohesion, thus reduces the deformation during transport for the same task completion time. Thank you very much, and I look forward to discuss this paper with you at the upcoming interactive session.